Welcome to the fifth lecture of Mechanics of Material. So let us have a rewind what we have done till now. So we are in the process of learning how to analyze a truss system. Okay. So we said that there are two methods to solve a truss system. Two major methods. There are other methods also. So first method was method of joint, and another method was method of section. So in the last class we have completed till method of joint. Okay. In this class we are interested to learn how to solve the trusses with the help of method of section. So let's see that what are the key points that we should take care while using method of section. So first thing is what is the basic difference between method of joint and method of section. So the key point here is that method of joint uses equilibrium only at the joint. At a particular joint, you can apply the three equations of equilibrium. Okay. Whereas in method of section, here also you use equilibrium equation, but not at the joint, but at the section. Whatever section you want, you can apply these equations at that particular section. Okay. So what is this section? We will come to it. Okay. So the basic difference is equilibrium is used in the both, but in the first part method. In the first method of joint, equilibrium equations are used only at the joint, and in the other method it is used at the section. This is the basic difference. Okay. So what are the advantage of method of section? We already have studied method of joint. Now I want to know that why I have to use method of section. So there are basically two major advantages. First advantage is that if there comes a case where you want to calculate the value of force in any particular member, but you want to calculate for that particular member only. You are not interested to solve the whole truss. Okay, you want only one value. Okay, so in certain type of situation, method of section is very, very helpful, and you can get the answer without a lot of calculation. Okay. So second point is that method of section significantly reduces your calculation. Okay, but it will reduce the calculation only if you use this method of section very smartly. Okay, so the way you use the method is very, very important. Okay. So moving ahead, So next is what is the procedure to use this method. So as a first point, you should see whether the truss is a determinate truss or it is an indeterminate truss. Because if you want to solve anything with the help of equilibrium, okay, so you must be sure that this truss have maximum or this truss have the unknowns within the equations of equilibrium. So For that you need to first calculate the value of static indeterminacy. Okay, so first you have to calculate value of static indeterminacy. If this value comes out to be 0, okay, then only you can apply method of joint or method of section. For both there is same situation. If this degree of static indeterminacy is not 0 and greater than 0, maybe 1, 2, 3, then you cannot solve them by use of equilibrium equation only. You need some extra method to solve this kind of problems. Okay, so you must be sure that whether you can apply here method of section or not, or method of joint or not, then only you should proceed. Okay, let us say that now static indeterminacy is 0. So now what should be my next step? So your next step is your next step is calculation of support reaction. So first thing you have to do is calculate the support reaction. What is the third point? Third point is you need to cut the section and do the calculation. Okay, so when you cut the section, there are some important points. Okay, that before cutting the section, you should first decide that what actually you are trying to do. Okay, so if you this thing must be clear. Your objective must be clear first. Okay, I want to calculate this value of force. So to calculate this, I need to cut the section in this way. Okay, this is how you should think. Okay, it should not be like that. Okay, let's cut this and see what happens. No, first decide what you want to do, then cut the section. Okay, so we will see this in a question, but right now we are going through the procedure. Okay, so once you have decided that I want to calculate this value, then you cut the section. The next step is you have to apply the equilibrium condition. Okay, then you can calculate the value. So I have also given here a note that when you are writing these equations, okay, so you don't have to write all the forces in the equation. You have to restrict yourself. Why? Because you are considering the equilibrium at the section. So equilibrium at the section means basically external forces, okay, or internal reactions, and the flow within the forces should be in a balanced system, or they should be in an equilibrium state. So to maintain that, you can only consider this one, and this one. So what does this mean? We will come to that again in the question. Right now you should understand what you should include in the equation: support reactions, external forces, and forces in those members only, okay, which were cutted by the section. Not all members. Okay, only the members which are intersected or cutted by the section. Okay, so what is it? We will see that later. So okay, so I am talking about section. So what is section? Okay, and how should you cut the section? So that is I should say that is the most important thing to use this method. Okay, that is very first thing that you should learn. So as a thumb rule, you can use these 3 points. Okay, it is not hard and fast rule, but for convenience or for the preliminary idea that how should I think, okay, how should I cut the section, okay, what are the points that I should keep in mind, okay. these are the some of the thumb rules. So the first thing is that you should cut the section such that the section is cutted in two separate halves. Okay, do not cut the section like there is completely one segment of the truss. Okay, don't cut just one segment, it will be useless. Okay, so try to cut the truss in two halves. As an example, say suppose this is some truss, let us say this is some truss. So if you have to cut the section, how should you cut? Okay, sorry, how should you not be cutting? If you're thinking to cut the section like this is a bad idea. Okay, sometimes there is possibility that it might give you answer, but there will be many occasions where you will be stuck. So try to avoid such type of decision. Okay, how should you cut? This is the wrong way of cutting the section. Okay, how should you cut? You may cut like this. Okay, such that this is, let us say this is some support, this is some support. Okay, so this part of this half of the section, this part of the section is one part, this is the other part. Okay, so you should think before cutting. Okay, like it should not be like a partial kind of truss system. Okay, although it may give answer at some cases, it gives answer, but try to avoid it. Okay, so what are the next point is, preferably don't cut the section which have more than 3 unknowns. Okay, why 3 unknowns? Because you have maximum 3 equations of equilibrium for a 2D system. So if you have 3 equations, you can solve or you can calculate maximum 3 unknowns. Okay, so it is a bad idea to have more than 3 unknowns. If there will be more than 3 unknowns, you will not be able to come to a suitable conclusion. Okay, so try to avoid section which have more than 3 unknowns. Okay, less than 3 or 3 will work. Okay, so what is the third point? Cut the member such that all the members do not meet at a joint. Okay, so that, see here, the first section that I have cutted, this one, this kind of section. See, the member I am cutting, this one and this one is meeting at one joint. Okay, so if you are cutting such kind of section, then there is a problem that all the sections are passing from one point, from this point. So if you will try to write the equations of equilibrium, then one equation is summation of moment at any point is 0. This equation will vanish because all are passing through this point, and there will be perpendicular distance for all the 3 members will be 0. So it is a bad idea to try this kind of section. Okay, try to avoid such kind of section. Okay, so let's try to solve things so that how should I use the method of section. Let's have an example. So let me write the question. okay, let's say this is your question and you are required to find the value of force or member force in this PE member. Okay, so this is what question is asking, and since the question is asking for the force in only one member, so now you don't want to, or you will not enjoy the solving this much of the truss and then coming to the B. So it will be a difficult task or lengthier task. So you can solve this question, or particularly by method of section, very easily. Okay, so you are required to cut the section. Okay, so before that, calculate the value of VA. So if you will solve this, I am not solving here, the value will come out to be 500 Newton. Similarly, VD will come out to be 500 Newton. Okay, and by now I believe that you know how to calculate the support reaction. So I am writing directly, and so now let's say how to solve. Okay, so let's say I am cutting a section like this. Okay, let me say that I am cutting section like this. So the important question is why I cut it like this and not any other way. Okay, so how I decided that I have to cut like this. So the target member was BE. So since BE has to be calculated, I have to necessarily cut the member BE because it is to be calculated. Okay, so now I have to calculate this value. I don't want any other value or any other unknown in my equation. Okay, I don't want extra equation. So I can see that the section is cutting 3 members, 1, 2 and 3 members. Okay, I want to calculate this one and I don't want to include this 2 members in my calculation. So I can see that if I am going to apply summation of forces in the vertical direction 0, okay, if I will apply this equation, since these 2 members are in horizontal direction, they will not be participating in that equation. Okay, so I thought this first, then I draw this section. Okay, so let's draw another diagram. Let's say for section 1. So let me draw again. Okay, here it was 500 Newton, here it was roller support over which reaction was 500 Newton. Okay, and the section I cut in is like this. Okay, so the section I cut it like this, and what were the values? This was point B. Okay, so this was FBC, this will be FBE, and this was F. So this force was FE. Okay, so this is 1/2 of the section that it will look like this. Okay, this side of the section. Okay, so LHS of section 1 1. Okay, I am considering equilibrium. Okay, equilibrium at the left hand side of the section. Okay, so let me write this also. Okay, that FE comma FBE comma FBC are cutted by section, out of which two are in x direction. Okay, so I have written this. How I can use it? So let us say I am writing this equation: summation of forces in y direction is 0. Okay, so let us say that I am writing this equation. Okay, so in this equation, what are the forces that I have to write? Vertical forces, in which what should be the forces? Support reactions, external load, and the member forces that are cutted by the section. Okay, external force, internal reaction, and member forces which are cutted by the section. So let's say, what are the external load here? What are the external load? 500 Newton. So let's write it. Positive 500. Okay. Why? Because this one. Internal reaction 500. It is upward. So positive. What else? External load and internal reaction. Internal reaction, external load 500. Direction is downward. So negative. What else is there? These three forces, out of which this is in x direction, ignore it. X direction, ignore it. What force is left? FBE. So what is its value? In this one, this component will be in the upward direction. Let us say this is some angle theta. Okay. So what will be the vertical component? It will be positive F BE into sine theta. Okay. See, solve here. This will be 0 plus FBE into sine theta is equal to 0. So FBE come out to be 0. Okay. So I got this value. Okay, this value is coming out as 0. So this is how I can simply calculate any value of any value without doing much calculation. I just did this one. Okay, but the most important thing is you should observe this first. You should think of this first. Then you should cut the section accordingly. Okay. Once you cut the section, you have to apply the equilibrium equation, and you will be able to get some value. Okay. So this was a basic idea that how should you think, how should you apply the method of section. We will do one bigger question in the another lecture because time will not be sufficient. So thank you very much. We'll meet in another lecture. Thank you.